Bitcoin. You see the headlines, you hear about the wild price swings, and it's easy to think that's the whole story. But what if the real story isn't about today's price at all? What if it's about a revolutionary answer to a problem with money that's over a century old? Today, we're going to look beyond all that hype.
And get this headline is from over 100 years ago. Seriously, Henry Ford, the car guy, he actually envisioned a currency that was based on energy, one that couldn't be controlled or manipulated to fund wars. It just goes to show you that the core idea behind Bitcoin, creating money that isn't tied to some central authority, it's not new at all. It's a modern answer to a very, very old question.
Okay, so to really get that big idea, we've got to pop the hood and see how this whole machine actually works. The mechanics here, well, they're the key to absolutely everything else, so let's dive in.
Let's just strip away all the technical jargon for a second. At its absolute, most basic core, a Bitcoin transaction is nothing more than an entry in a book, a public book. That's it. It's just a simple message that says, hey, I'm authorizing the transfer of this value from me to someone else. So, what does one of those entries look like? Well, as you can see here, it's a lot like the double-entry bookkeeping accountants use. You've got your inputs, that's the Bitcoin you're spending, and then you have your outputs, that's where it's going. And here's the clever part. The total value of the inputs has to be just a tiny bit more than the outputs. That little bit left over, it's not lost. It becomes an implied fee that rewards the people, the miners, who process and secure your transaction.
Right, so where do all these millions and millions of transactions actually live? They live on the blockchain. And you can just think of the blockchain as this massive shared public book that anyone in the world can look at. Every 10 minutes or so, a new page, a new block full of transactions gets added, and it's cryptographically changed to the one before it. This creates a permanent, chronological, and pretty much unchangeable record that goes all the way back to the very beginning in 2009. So, having this public ledger system leads us right to Bitcoin's most important innovation. It's all about solving the problem of trust. Specifically, how do you trust a financial system without needing a third party, like a bank or a government, in the middle of everything? Which, of course, brings up the million-dollar question, right? If there's no CEO, no central office, no one person in charge, how in the world can you possibly trust that the book is accurate and that nobody is cheating the system? Well, this is actually a famous problem in computer science. It's called the Byzantine generals problem. Picture this. You've got several army generals surrounding a city. They all need to agree on one plan, either attack or retreat, but they can only communicate through messengers. The real problem is some of those generals might be traitors, sending fake messages to screw up the plan. So how do the loyal generals all agree on a single shared truth? And this is where the genius of Bitcoin really shines. Its elegant, powerful solution to that age-old problem is a concept called proof of work. This is the magic that allows this huge, decentralized network to agree on what's true. Now, this proof comes from a process we call mining. In the simplest terms, it's like a giant competitive guessing game. Computers all over the world are burning real-world energy, racing to be the first to find a very specific number. The computer that finds it first wins the right to add the next page of transactions to the book, and as a reward for all that effort, they get brand new Bitcoin.
And that is the crucial point, tying the security of the network to real-world energy. This work is the secret sauce. To go back and change a transaction, a bad actor would have to redo all of that incredibly difficult computational work, not just for that block, but for every single block that came after it, all while the rest of the world's computers are still racing ahead. It's basically computationally and economically impossible, and that is what makes the ledger trustworthy.
So as you can imagine, this technology isn't just a niche interest for computer geeks anymore. It's having a real-world impact, and that means governments, especially here in the United States, are starting to pay very, very close attention. And in the US, this has created a fascinating regulatory tug-of-war. On one side, you have the SEC, the Securities and Exchange Commission, and they tend to think most digital assets look like securities, like stocks. But on the other side, you've got the CFTC, the Commodity Futures Trading Commission, and they've argued that a decentralized asset like Bitcoin acts more like a commodity, like gold or oil. They're both looking at the same thing and seeing something completely different. So all this confusion has prompted Congress to try and step in. We're now seeing proposals for new laws like the Clarity Act, which tries to create clear definitions, and the Genius Act.
That one would set up rules for stablecoins. Those are cryptos pegged to something like the US dollar, while officially treating Bitcoin as a commodity. Really, the goal for everyone is to get out of this legal gray area and just have clear rules of the road. And listen, this isn't just some theoretical debate. This stuff is being used on the world stage right now. A report from the Rand Corporation found that Russia is actively using cryptocurrency to trade internationally and get around economic sanctions. It's a powerful reminder of what a neutral, borderless financial tool can actually do.
All right, so where is all this headed? What does Bitcoin's next chapter actually look like? Let's take a look at some of the challenges and the really interesting innovations that are on the horizon.
First off, the scale of this network is just staggering. To give you a real sense of it, this slide shows that just one publicly traded mining company is planning to use 540 megawatts of renewable energy. That gives you an idea of the massive, real-world industrial infrastructure being built just to support and secure this digital system. It's huge.
But it's not all smooth sailing. There are major hurdles to clear. First up is scalability. The main blockchain can only handle so many transactions at once, so people are building solutions on top of it to make payments way faster and cheaper. Then there's long-term security. Right now, miners get paid in new Bitcoin, but that reward gets cut in half every 4 years. Eventually, the transaction fees alone will have to be enough to pay for all that security. And finally, there's evolution. The network is always being upgraded with new features for things like privacy and efficiency.
And that brings us to the final and really the most important question. After seeing how it works, how it creates trust without a central authority, and how the world is starting to grapple with it, what is Bitcoin really? Is it just a volatile, speculative asset? A passing digital fad? Or are we looking at the foundation of a new, truly global and permissionless financial system? Well, the truth is, the answer to that question is still being written.